Alright, time for another draftphysics.com, debatephysics.com. Likewise, also video presentation. Alright, so in this series of videos, try to be brief and keep it to one subject. And the idea is to solicit, if possible, a response from physicists, explaining how they have accounted for or they do recognize facts regarding how things function. Now, the subject of friction is kind of interesting because a lot of physicists talk about it as if it's a force. Now, this might just be a convenience because it makes diagramming equations easier and accounting for a better representation or modeling. I would argue that it's just deception, and it just makes it's a deception. It creates a false impression. So I'd argue that friction is just contact. Okay, you could call it contact force, but there's no force involved except the event of collision. It's just usually in the case where it's a tangential or peripheral collision with something, and it's something that can reduce the motion into movement of molecules instead of a whole object. And that's all. So it's just a collision with the interior of something. So it's almost like you could say sonar hitting something and then vibrating the inside of the person or something. It converts it into a much more subtle motion that's more involved with the forces that hold the atoms together. And that kind of interaction, sort of like electricity, you could argue. Heat is a lot like electricity, and heat's probably the most common conversion that friction creates. So it's just a sink. Contact with a big surface or a large object, it just becomes a sink if it's not perfectly elastic. So if there's any inelastic component to the contact, it means that you would dissipate your energy. Alright, so there's a simple experiment that on its surface indicates something, and I'd argue that it's just a superficial view that indicates that. So you could roll two objects, one at, let's just move this over a little, one velocity and the other one at 2, so the same mass. And you could roll them on a surface, and the fact is they'll both lose their energy at some point. And the whole argument is that all of their energy, all of their linear motion is converted to an equal amount of motion in the surface, the ground, or in the form in atmosphere of sound and other things. Now, so you can do the experiment, in a vacuum, and you'll get the same results. The ball will still stop, and it's going to stop because gravity is creating friction. And you could, literally change the position of the experiment. That is, you could drop something next to a brick wall and just apply a force, a wind or some other mechanism, little beads or sand or anything, and just push something into a surface and create friction. And you'll do it in exactly the same kind of manner, in the sense that the faster you move through the force pushing, because they're all time-dependent forces, the less it pushes, the less you weigh, the less the object pushes into the object. So you can understand that under gravity, which is a time-dependent force, it's 9.8 meters per second over 1 second. It's not seconds squared. Okay, so even that is a subject in itself, because it's clearly a perversion of the formula to say 9.8 meters per second squared, because it's clearly 9.8 meters in 1 second increments. That's the actual formula. That's the reality. 1 second, you get this much added velocity. It's that simple. The truth is revealed in the experiment. So you can understand that something going 1 velocity will do this distance. Something going 2 velocity will go, it'll go 4, and it might even go a little bit more. because of the change in the friction, actually. And what you can understand, that there's a point where this ball will go one velocity, and you can know for certain what one velocity looks like. So you know this experiment here will be identical to this experiment here. And it will take the same time. This will be 1 unit of time, 1 unit of time, and the friction will be identical here that it is here. And it's a pretty good giveaway for what you can understand to have taken place when it was going faster across the surface, which is you're basically reducing the friction by moving it quicker through the gravity. So I could take a regular scale and implant it in that surface where the ball rolls. And the fact is, the faster the ball rolls over this hunk of surface, the less it will weigh. So at the end, when it's almost going to stop, it's going to almost weigh its full weight. And when it's going quite fast, it's going to weigh much less than its full weight. So obviously, the force pushing the object, forcing it to make contact with the surface, forcing the contact, is increased as the object slows down. So the friction here is obviously much less than the friction here. It isn't a constant friction. It's not a constant force of friction. The force down isn't creating an equal and opposite force up, in the sense that over this entire surface per inch, per inch, all of this just gets the 9.8 in weight, if you thought of it as weight. If I just said it's 9.8 pounds of force, it's 9.8 over this entire surface, and then it's 9.8 over this much smaller surface. Same pressure on the small surface that's over this entire surface. So you can understand that obviously per inch there's a lot less ground getting disturbed, there's less heat, in simple terms. And so although this looks like, because it went 4 times the distance, it did 4 times the work. In this case, we're almost using it like a joule tank. You're basically just saying, I'm going to convert all of the linear motion into friction, and the friction is going to be expressed ultimately as heat. And so I'm going to have heat in the ground. And the simple truth is, I'm only going to have 2 units of heat here, not 4. So even though it travels 4 units of distance, there's only going to be a total of 2 units of heat. Because it only did 2 units of work, because it only had twice the momentum, and it's momentum that actually makes heat. It's just a fact. Momentum always has to be conserved. And frankly, momentum is the only force or energy there is in the universe. There is no 1/2 mv squared of energy. So it might look like 4 units of work, but you can know it can't be, because it does progressively change with velocity, and obviously it's going to be less friction here than there is here. And it's just an absolute fact. And this is why you can slide across thin ice, is because you can change how much you weigh, literally, by increasing your velocity. Because it takes time to weigh your weight. You don't weigh your weight instantaneously. The scale doesn't move instantaneously. It takes time to weigh your weight. And the faster you go, the less you're going to weigh. So it's pretty clear evidence, in the sense that it takes an experiment that creates the impression that there's something like mv squared, just like a bullet might create the impression that it has 1,000 times more energy than the recoiling gun. But it's an impression. The bullet doesn't actually move more matter. The bullet won't create more heat. And the rolling ball going 4 times the distance looks like it's doing more work, but the fact is less energy was pulled out of it per inch for most of the time it was traveling, for at least half the time. there was a substantially 1/3 of the weight. So if you took an average over this average, this weighed 1/3 the total weight. I think it's 1/3. Yeah, I have to think about it a second. You were weighing 1/3 your weight because it's 3 units of distance. And, yeah. 3 units of distance, yeah, it has to be 1/3. So you weigh 1/3 of what you weighed here. And, it demonstrates that, science can have, elements to it that are more complicated than just a superficial impression. And so regular physics has given people the superficial impression that there's some counter force that's actually creating a disturbance of some kind. And all it really is that this has linear motion. And if I force it to make contact with the surface, it's like this surface is a bunch of little tiny bowling pins. So if you thought it was a bowling ball, the surface is like a lot of little pins, and it's going to give its momentum away to those little pieces. And eventually it's going to run out of all of its momentum. And all of its momentum is going to be right here in heat. And there isn't going to be any velocity squared amount of momentum. There's just going to be mv, no mv squared. All right, that should be enough. But I would argue this is decisive evidence against kinetic energy theory, and it demonstrates the reliability of momentum and demonstrates that yes, you can cheat the truth, or you can respect the truth. And the argument is this is the truth. There's only twice the heat here. And the fact is that physics has had the technology to measure these realities, and they haven't. They haven't done any of these elemental experiments that will demonstrate that the only thing in the universe that does any work is masses moving velocities, not masses moving velocities squared. Alright, that should do. Yeah. Till the next time and such, and so forth and whatnot.